Hi friends, have you ever had experience of your batch processing job stuck for hours and days? A batch processing job contains usually 3 steps: read, process, and write. And it can be run in one machine or multiple machines. So today, we're going to focus on one machine optimization. And we'll talk about 4 solutions that can speed up your batch processing job. Let's get started. So we just talked about a batch processing pipeline on a high level contains 3 steps. The first one is read data, and then secondly, it processes data into some desired format, and lastly, it will write the end result. So the very first step is to identify the bottlenecks. How can you do so? You can profile your whole pipeline. If you find that your pipeline spent the majority of time on read and write, then it is an I/O-bounded application. And if you found that most of the time are spent on processing, then it is a CPU-bounded application. In this video, we'll focus on one machine optimization for your batch processing job. And for that, we'll talk about optimization from these 4 perspectives. First of all, you can always horizontal scale by adding more parallelism. But also, there are other ways to optimize by identifying bottlenecks in data and compute, and use more compact and efficient data. And lastly, just upgrade your machine. Let's go through this one by one. So the first, most obvious solution is to add more parallelism. You can do so by adding more threads or use more processes. So if your application is I/O bounded, that means your application spends most of the time read and write, interacting with storage or externals. Then you can use more threads. The difference is that threads share memory, whereas processes don't share memory. I/O bounded tasks spend most of the time waiting for disk reads, network requests, or database queries. During these wait times, the CPU sits idle, and threads can share memory and are relatively lightweighted. When one thread is waiting for I/O, it can release control and let other threads run. So even with Python's GLL, Global Interpreter Lock, threads can work well here because they are mostly spent on waiting, not computing. In contrast, for CPU-bounded tasks, they need actual computation power. In Python, the GLL prevents multi-threads from executing Python code simultaneously on different CPU cores. If you can use multiprocessing, then each process has its own Python interpreter and they don't share memory. Each process can run on different CPU core, achieving true parallel computation. So after you've done the profiling, you'll be able to tell whether your application is I/O bounded or CPU bounded and add the corresponding parallelism. The second perspective to solve this is to move data and compute closer. So what we're first seeing is to avoid cross-region data transfer. So if you are using machines in one region and your data is in another region, that means that your data has to travel across region to reach your compute, which is usually time-consuming and expensive. And secondly, I want to give you a concrete example. So when you want to process data from BigQuery, Google BigQuery, sometimes people would just directly load the BigQuery data into memory and then process. My recommendation is that if possible, you can use BigQuery to calculate or do the computation. You should do that in BigQuery rather than load it into memory and then process. When you load BigQuery data into memory, you are actually moving data to your compute. There's a data transfer cost. If your function and method are simple enough, you can move your compute closer to the data by using BigQuery custom functions to do the data transformation. And this way, you are moving compute to data. This is especially helpful if your dataset is too large to move. The third perspective is to use compact and efficient data. So by data, I mean these 3 categories. You want to use the right file format to accelerate your read and write. So for example, Parquet is column-based. When you read it, you can read one column only. And H5 is also known for its fast read and write, but CSV is relatively inferior compared to the two counterparts. And when the data gets in your memory, you want to use the right data structure to store your data. So if you're using CPU instead of list and array in Python, you should prefer to use NumPy, which is optimized for list-like data structure. And if you're using GPU, then tensor is the better choice. If you're talking about data frame object, then parallel is usually more compact and efficient than pandas. And actually nowadays, you can use parallel as a backend for pandas. And lastly is to upgrade your machine. Depends on what you do. For vectorized operations, GPU is your best bet, but on the other hand, it is also expensive. So the alternative is that you can use a bigger CPU machines by having bigger memory and more cores. And also, SSD helps a lot, especially when you want faster read and write. It reduces your I/O burden. Here's a quick recap. In order to optimize and speed up your batch processing job, you want to profile first and identify whether your application is I/O bounded or CPU bounded. And based on that, you can add parallelism. If it is I/O bounded, you want to add more threads. If it's CPU bounded, you want to use multiprocess. Another trick is actually to reduce data movement. Avoid cross-region transfer and try to move compute to data if your data is too large. And next thing is that to optimize your data, use efficient data format like Parquet or H5 file when you interact with I/O, and use NumPy or tensor to process list-like object. For data frames, try to use parallel. Lastly, you want to upgrade your hardware if possible. That's it. We'll see you next time.